This video is a bit different from the others because prototypes aren't components. But the ability to try things out quickly is just as essential as knowledge of the individual parts for me. Prototyping is such a broad subject though, I'm really just going to look at my own experience of making prototypes and the techniques that I find useful when making my machines. Though I guess I do hope it also may tempt other people to try physical prototypes in this digital age when everything's done on CAD. As always, here's the chapter list to skip to any particular part of the video. I thought I'd start just talking a bit about drawings and how they relate to prototypes. When I was younger and had less experience, I couldn't really picture what the finished parts would be like, so I was better off just plunging in and playing with materials. But it is definitely useful now as a way of problem solving. I like drawing. I used to be a cartoonist for 15 years. But I always get to some stage where I know I need to stop and should actually make the part. It's easy to get sucked in and spend too long drawing, I think. And I think the heart of the way I design my machines is more in the prototyping than actually in the sketching that I do beforehand. Once you've done a drawing or decided to start work on a prototype, there are just so many ways to make prototypes. I think I'll just start with one of the simplest. When I was a kid, I used to make things out of cardboard and sellotape, and it's still very useful for making prototypes. The only tool you need is a pair of scissors really, and some tape. What I'm actually trying to make is there's a compartment to put your foot into for one of my machines. I'm not quite sure how it's going to work out yet. I like boxes for tins of beer. They're about the right thickness. Card. I could probably do this more accurately with a Stanley knife and a straight edge, but this does work. So that's the sort of finished shape. And of course I could go on adjusting it for ages. It's particularly useful, I've now found, cardboard and tape, if I want to make the final part out of thin stainless steel, because I can now work out where I would want to cut the stainless, how many different pieces I would need, and also the pieces I can just fold from the original shape. So I would then draw this shape onto the bit of stainless and fold it into shape. This is what the final thing looks like. Once I've made it in stainless, I obviously weld the joints, but then you can sort of blend them so they all blend into one just by grinding it back. So if I want to mock up something bigger, I usually make it out of chipboard or OSB, just with a wooden frame, just screwed together. This was actually the last arcade machine I made to get an idea of the size of, and height of the drum. You can see the construction is really quite minimal. It's just sort of battens of 2x1 that are just screwed into the board. It's very quick to do. I've made entire rooms like this when I was working for museums as a designer. It's quite hard to envisage the sizes of spaces, and I found that really helped. I don't know why architects don't do it for their clients when they're designing houses for them. I had a friend whose house turned out much bigger than he was expecting. He's a bit horrified really. Difficult to keep warm. So yeah, I think it's very worthwhile doing that. In the 1950s, when the first nuclear submarine was being designed in America, the man in charge was an Admiral Rickover. a man after my own heart. He insisted on a full-scale wooden prototype of the inside of the submarines, complete with all the pipework and machinery. And he spent ages inside checking that each bit could be pulled out and replaced for maintenance and stuff, and also that the crew could move smoothly around inside without too many obstacles. At the time, even at the time, it was seen as quite eccentric, and it cost a fortune to make, and of course nobody would do it now. But yes, a man after my own heart. For accurate scale models, I like foamed PVC. This is the stuff that estate agents often use for the for sale boards outside houses, and it's also quite widely used for architectural models. We made one a couple of years ago as the background for some animation.
Good job! You have been awarded an A+ grade with distinction for your driving skills.
And it's really, you can be quite rough and ready with this stuff. You can tape it together. It actually glues well with plastic pipe welding glue, and it's easy to sand and easy to cut too. You can get surfaces very flat with a disc sander, for instance. I use that quite a bit. This is probably the most elaborate model I've made out of foam PVC. It was for a large clock I made for London Zoo. I made this while I was designing it, before we started fabricating it, just to think through the overall shape. And I know most people would now do this with CAD, but I rather like playing around with bits of plastic or bits of card to think through a problem rather than sitting at a computer. And I also think that I get more information out of a physical model, flying around it, rather than the virtual way of doing it on a computer. But then that's probably just my age. I also occasionally make wire frame models. This is for a clock that was, the people are life size, so it was actually sort of 20 or 30 foot diameter, this clock. And it's made up of bits of welding wire, 2.4mm wire, which is copper coated steel, and they're tack welded together with my MIG welder. I'm going to talk a bit more about tack welding later. In this case I actually laid it on top of the CAD drawing and built up the model from the drawing. Again, it helped me to sort of think about the design, but also I then took it to the company that was fabricating the structure, and the welder thanked me a lot for leaving him with the model. He said it made his job a lot easier than just relying on the drawings. So these sort of prototypes have a lot of different uses. Well, a video about prototypes wouldn't be complete without mentioning Lego. I didn't grow up with it myself, so I've never got into using it. But I can see if you did grow up with it, it's a good way of trying out shapes. Out of curiosity, a while ago I did buy a Lego Technic robot thing. And I was impressed by the software. It's very simple. I think it's lost its memory now, although it still does just about run. Whoops. This is one of the problems with Lego, is I find the blocks fall to bits too easily. And also for making mechanical things, it's very limited by scale. You can't make really tiny things or really huge things. And complicated things, I think you'd be limited because the blocks would be falling apart. Though people obviously have done it, so I apologise to all the Lego fans that I'm not a fan myself. The fancy aluminium profile prototyping systems are very ingenious. They're fun to use, and the only power tool you need is a chop saw to cut the aluminium profiles to length. You can also bolt motors and sensors and other things to them, so they're good for developing entire machines. Though the cost of the parts quickly adds up, they're particularly good for developing short runs of machines, like for factory automation. So then, once you've perfected a prototype, you can order all the profiles pre-cut to the right lengths and all the parts, and then it's very quick and easy to assemble an entire run of the machines to copy the prototype exactly. I've made a couple of machines with this structural aluminium section, and instant weight loss is one of them.
Your body mass index is low, but if you want to look like a supermodel, you still need the instant weight loss diet. And
I used this aluminium system because I wanted the machine to look sort of scientific and medical, which it does well. But it was fun to use. It's very strong, it's quite quick, and it's quick to change things too, which is good. And it's good that you don't have to paint it. It's anodized aluminium, which is very tough. On the downside, it's quite pricey, not cheap. Dirt gets into all these little channels and things, so it's difficult to keep clean. And the other thing, the most serious problem I find, is if I'm short of space, it's not the best way to make a mechanism as small as possible. And that's quite a big factor in a lot of my machines, so I don't use it regularly.
Welcome to Laboratoire Hunkin'e, harnessing the power of nature to bring you weightless nutrition. Please wait while our precision-engineered system individually prepares natural, weight-free nutrients for you.
Don't take your eyes off it, or you will miss the amazing sudden eruption of cosmic energy.
"3D printers have been overhyped, but for industrial prototyping they're certainly serious tools. Now most metal parts, and also the moulds for most plastic parts, are made by CNC tools. All the designs are generated in 3D CAD, so 3D printers are the perfect way to prototype them. People are also more experimentally trying enormous 3D prototyping machines to make complete rockets or even complete houses. They're also great for people who've grown up used to using computers but without the traditional metal bashing skills that I take for granted. But for me, developing my machines, I don't need 3D CAD models and don't want to spend any more time on my computer than I actually have to. Compared to how I make my prototypes, 3D printing seems very slow. It can often take 12 hours to make a single part. And the affordable ones, the affordable 3D printers, only use rather nasty plastic, which aren't strong or easy to modify or repair. The process of prototyping that I use most often, particularly for mechanisms, is just to weld bits of steel together with tack welds and then grind them off if I need to change the prototype. I do this with my MIG welder. If you're unfamiliar with these, I have an earth wire that you clamp to the thing you're trying to weld, or in this case to my welding table. And then they have a torch and a spool of wire in there, And when I pull the trigger of the torch, the wire comes out the end. When it reaches the earth on the table, it completes the circuit and gets hot. If it was right by the torch, it would be hot enough to melt the wire. And that's what forms the weld. So making a tack weld is actually very, very simple. If I wanted to weld these two bits of steel together, turn the welder on, I always cut the end of the wire off so it's got a nice clean tip and it'll conduct well when it first touches. And then literally you just have to hold the torch over the joint and weld. Pretty strong. I'd have trouble breaking that weld. I sometimes actually do tack welds that are quite a bit smaller than that. It's pretty flat. You can, though, at this stage adjust the angle a bit by I think it's a fraction tilting over to that side. Yeah, I think that's right. So you could adjust the angle before adding extra tack welds if you need to. Actually, I don't usually just rest bits of metal on the bench like I did for that tack welder. Much more common, I would actually clamp them together, because if we clamp them together, obviously I can get an angle completely exactly right. So if I want that to be a right angle, oops, I can just, that's pretty good actually, tap it until it's in the right place. And then of course I can tack weld it in place. And for something like this, I would probably do the second tack weld on the other side. And then you actually get something with a really useful amount of strength. So the settings on this welder, it's a 160 amp welder. I use it at maximum power to get better penetration in the weld. 0.8mm MIG wire, and slightly unconventionally I use CO2 gas rather than the normal argon mix. This is historically because I could get it cheap from the local brewery, but it is supposed to have more penetration. The welds are hotter, but the downside is it creates a lot of spatter, so it's quite a lot more messy when that's important. Another thing about this welder is that to the beginner it all looks rather scary, the white hot metal and the sparks and everything, and certainly when you're starting off you need to do all the health and safety stuff and take it seriously, but as you gradually get more familiar with it, I don't really see this as a scary tool. I like to think of it as just as a glue gun for steel, and I seamlessly mix between drilling a hole or cutting a bit of metal and welding something to it and turning a bit on the lathe. It's just another process in the workshop. Of course then sometimes I have to make changes, and that's where the grinder comes in, the other part. Now I use an angle grinder, and I like particularly fine, thin discs. This is actually 0.8mm thick. The normal ones are 1mm thick. It doesn't sound much difference, but I think it makes a really big difference. and these just cut through steel like butter. But unlike the welder, these are, I think, are more scary than they seem. I have cut myself with them in the past and it's not pretty. I do try to always do the grinding in the vise. This means I can keep 2 hands on the angle grinder. I don't usually go all the way through the welds. I find that it's easier just to go almost all the way through, and then I can just tap it off with a hammer. Well, this simple technique of welding bits on and grinding them off again is incredibly versatile and I don't know what I'd do without it, really. And I don't know, it may jam or want to destroy itself, I'm not sure. No, not at all, it's perfectly happy. I haven't got any particular use for this mechanism, but really you could make a linkage like this in half an hour or so. I'm going to illustrate my approach to making prototypes with this machine, Supercycle. It's the machine I made this summer for the arcade. Well done, but your coach can help you do even better. So put your ear to the intercom for some confidential advice.
As a qualified doctor, I can help you boost your performance. Insert a foot into the cowl at the bottom of the machine and you will feel a secret raised patch. Simply press down on this during the race to inject more power to your muscles.
And actually the machine is just back in my workshop for a week for some modifications. So I'm not remotely sporty, but I do sometimes find the cat and mouse game between the doping and the policing of it entertaining in a bonkers sort of way. And it seemed like a suitable starting point for one of my machines. So, and cycling, a good hotbed of doping, and also nice for mechanical models. And I actually started with making models of cyclists with pneumatic muscles. So there's one for each, there's one for a thigh muscle and one for a calf muscle. And I thought perhaps you could control 4 pneumatic rams to make the cyclist propel the cyclist along. But actually it was very difficult to do. It wasn't really intuitive or certainly not satisfying. But I didn't give up. I kept altering this prototype and ended up with this version, which just has a single ram, a single thigh muscle, but with a flywheel and a counterweight. So and if you get the timing right, you can get quite a good speed going. But I mean, I've done that quite a few times. I think if you're a beginner or a kid, you might not get the idea. So it might not be at all satisfying. It quite often goes backwards rather than forwards. But because I was working on this for quite a long time, there are many, many modifications, and you can see the little tack welds all over the place. Well, I didn't give up at that point. I persevered. Next, made a version with an actual cycling figure on it and more the right shape. But this didn't work so well. There was just sort of more friction in the motion, and I think I just thought the whole thing was a bit clunky. So I think after this one I did finally give up and decide to start all over again. There's not time wasted. All the time I've been thinking about the general ideas about the machine and reading about doping generally and the rest of it. And once I'd abandoned the idea of the pistons, then the cyclist could be much smaller. And that opened up a lot of new possibilities. With the smaller cyclists, I had the idea that they could race round the rim of a real bike wheel. So that's where that idea came from. This next prototype, I've included a motor so that both the motor and the crank have freewheels on. So whichever is going the faster controls the speed that the wheel goes round. So that seemed to work, and at the time my idea was that the cyclists would go all the way around the wheel. There was a friend who suggested they should stay at the top, and I wasn't keen on the idea to start with, but then I thought of a way of doing it mechanically that rather appealed to me, using differential gears. So I made this quite elaborate prototype to see if it would work. The differential gears in the front is connected on the sides to the two cranks that you turn, and the output going to the yellow flag at the back on the right is the average of the two input speeds. Then the rear differential, the shaft is connected on one side by chain and the other side by gears. So the gear side is now rotating in the opposite direction. Anyway, what this means is that the rear differential is now measuring the difference in the speed. So if the right-hand one goes, right-hand crank goes faster, it'll move one way. If the left-hand crank moves faster, it'll go in the other direction. It was fun trying to get that to work, and obviously with that there's less welding and more fiddling around on the lathe to make that prototype. But I was encouraged by that and went on to build a more complete one with the bike wheel and positions for the cyclist. And increasingly I felt that this was going to work out. And in fact this became the core of the entire machine. So once I settled on the core of the machine, I could make this mock-up of the final shape. It's really very rough, but you know, I can kneel down and pretend to be a child, check that I can reach the cranks and check the viewing angle for looking at the little cyclists. And then there's always something unexpected. In this case, it was useful, I hadn't thought of the clearance between your knuckles while turning the cranks and the edge of the disc. So once I was happy with this, and I think this changed shape once or twice while we were making it, then I could weld up the frame, the external frame for the final machine. Once you've got the frame and you're adding bits to it, it's great being able to design the next part with being able to see exactly the space that's available to fit it in. It's much harder to do it in abstract just on a computer if you haven't got all this stuff to actually look at while you're designing it. That wasn't the end of the prototypes though. So although the machine was coming together quite well, I still had no idea really quite how the game was going to work out. I managed to get it in a state where it was just playable before my grandchildren came to stay at half term. Jessie pointed out the obvious snag. What on earth is to stop people just keeping their foot on the doping pedal for the entire race? And it had been at the back of my mind, but I'd been kind of hopelessly searching for some sort of way of integrating doping tests in the game. But it all seemed a bit clunky, so I kind of left it. But then Jessie said, oh, it's obvious, they get an overdose. And I hadn't thought of that. I was being much too literal about the doping tests, but the overdose is just a simple device to make it into a game. And I always have to simplify my ideas, and people still get the gist of what the machine's about. It doesn't matter at all. So really, Jessie's was a genius stroke. And once with that idea, then the rest of the machine came together really quite well, and was on the pier for the beginning of the summer holiday. Congratulations, you have both completed the tour and are now true professional cyclists.
I'm a loser.
So one of the things I want to change on this machine are the foot switches. The idea is that when you press down on them, that they actually move. Give a sort of sensation that the drugs are being injected into you. But the trouble is, people are just so wildly enthusiastic about turning the cranks, they just don't notice. The movement is too subtle. So to change it, I need a more powerful motor. But I'm fortunate that I found these beautiful ones in the store. Something Rex found in the scrapyard many years ago. And I think these will have plenty of power, though the foot pad will have to be a bit further off the ground, so I'm not quite sure how it'll work out. So that's what I'm going to prototype. So the first thing, to make the wobble, I'm going to make an eccentric to go on the motor. This particular prototype involved less welding and grinding than I was hoping to demonstrate. But then every prototype's different. They're always a mix of lots of different tools in reality. And here is the finished eccentric. So that'll go on there on the flat of the shaft, and then grub screw goes in here, and then I made the outside the right size for this bearing. So now when I connect it up, so that's the motion I'm hoping to get on my foot. Most of the bits of steel I use for these prototypes are just bits out of the scrap bin, so this will do for the foot plate. So the next thing is to mount it on a plate with a hinge to see how it would actually feel on my foot. Now what I need is a spring to keep it up and a switch to activate and turn on the motor when you press down. So I've got another couple of bits of scrap, any old stuff will do from the scrap box, to make up this bracket. So this is where my Wogo comes in. This reminds me really that having like stores and lots of stuff is actually an important part of prototyping quickly, just to be able to go and pick the stuff up rather than to wait for the next day until it turns up with carrier. One last thing, I've got to cut the top of the motor shaft off so that it's flush with the eccentric. And now it's ready for a test. Actually a bit disappointed really. I sort of thought that it was going to be a bit more dramatic, the feeling, and I thought, but I think I'll go the next stage and make a version that actually fits in those cowls that I can try while playing the game. So I've now mounted the motor on a sort of frame that will fit in the machine, also with the stainless housing. I put the hinge pin up at the top this time, so that you can rest the whole of your weight of your foot on the edge here. So we'll see how that works. Well, another disappointment, I'm afraid. I think it's just much too far back, the wobbly bit, the eccentric. It needs to be much closer to the front to get the ball of your foot to feel the sensation strongly. So I'm going to have to change the motor around. To try and give a better feel of how I prototype, I've filmed this stage in real time, but sped it all up. The process does look chaotic, particularly because so many of the prototypes don't quite work out. But though when I was younger I found this frustrating, I now really enjoy it. It's only when things don't work out that I learn something new. But equally, it's still really exciting when something does work out well. Much better. So now you kind of have to put your weight on the moving thingy, and then you feel it a lot more. Oh, it makes a difference. So I'll now put the stainless housing on and see if it still feels good. It also looks very messy. I don't understand why the modern engineering world, everything has to look so clinically clean. So, I really am hoping now I've got it just about right. So, where's that? That's my stop. Looks exactly the same. An extra trial down there. I think that'll do. Probably as good as I'm going to get it. I've now just got to make both of them and kind of tidy it all up a bit. The number of holes in that plate was just extraordinary. I actually found it surprisingly hard to film the process of making these new footrests. Once I get really absorbed in the making process, it's hard to stop and film. And just in this last stage of putting them back in the machine, I decided it was actually just too uncomfortable, the strange angle of your foot. Now I've made the footrest higher, and you need to put your weight on the foot. So then I realised I could add a sort of front rest to put your weight on, and then you just have to rock your foot, and it made it a lot more comfortable. So really, making prototypes can go on just until the minute before it goes on the pier. Well, that's the end of this video. I hope you found something useful. It was very much my personal approach to making prototypes. I think you might feel that the way I developed Supercycle was a bit too chaotic and haphazard, but I would argue it was actually very efficient. From the time I just started making that first prototype of the cyclist until the finished machine got on the pier was less than 6 months. And it's lovely to see people enjoying using it now. Another thing I was thinking while making the video was how much of a jack of all trades I am. I take it for granted, but other people seem to think it's unusual. They think I'm a freak or an amateur, or occasionally more flatteringly as a genius, but it used to be common to be a jack of all trades. It's just recent, our obsession with qualifications and experts, that we seem to have forgotten about its value. My daughter recently found this quote: "Jack of all trades, master of none, but oftentimes better than master of one." I guess that just about sums me up. Bye.